Every year in the remote cold wetlands of the Adirondacks, plants grow and die, but do not decompose. These are peatlands, known as bogs and fens, and they are the product of 10,000 short summers of plant growth since the glaciers retreated. Adirondack peatlands are among the southernmost examples of this boreal ecosystem in North America. They provide valuable ecosystem services like flood mitigation, carbon sequestration, and clean water. Peatlands are a rare wetland system in the Adirondack region and contain a unique biodiversity. But even more rare among Adirondack peatlands are its patterned peatlands. Patterned peatlands have organized microtopography, high spots called hummocks and low spots called hollows. The hummocks and hollows appear as ribs or a washboard pattern and can stretch over tens of meters. Patterning of peatlands is an ecological phenomenon that intertwines global-scale climate, local-scale topography, and micro-scale plant competitive dynamics. Temperature and precipitation are the climate drivers that control peatland formation. Peat can only form where annual precipitation exceeds water losses from evapotranspiration. Peatlands of the Adirondacks are often positioned high up in watersheds. Thus, watering entering peatlands comes mostly from precipitation, which is nutrient poor and acidic. Gently sloping topography is also critical to patterning. As peat accumulates, water moves as sheet flow across the organic soils. Low spots are wetter and support sphagnum moss growth. High spots are drier and support vascular plant growth. In low spots, sphagnum moss is highly competitive because of its efficiency at gathering nutrients and acidifying the local surface water, creating conditions preferred by sphagnum mosses. In higher spots, vascular plants become more established, shading out the sphagnum mosses and transpiration of more water, creating the drier conditions preferred by vascular plants. Over time, these plant groups come to control the environmental conditions of their own microsites, creating conditions that favor their own persistence. It is this microsite diversity that greatly increases the species richness of patterned peatlands. Essentially, one plant community occurs in the slightly wetter areas, and another plant community occurs in the slightly drier areas, just a few centimeters apart. The ecological phenomenon that creates patterned peatlands is a result of stable climatic conditions, particularly topographical setting, and unique plant species compositions. These highly biodiverse ecosystems are extremely vulnerable to even slight changes in climate, and this is especially true in the Adirondacks, where these ecosystems are at the very edge of their global distribution.